Good morning, and as always,
Slow is smooth, smooth is fast.
so we talked about two different words, this idea of distance and displacement in our previous video, and we really want to expand on those ideas, as we will with all those different words, in what that means.
So take a quick second, pause the video, read these 4 questions, and try to answer them.
Okay, so this is a simple question of whether someone's walking 3 blocks north, 4 blocks west.
And we want to know where they are, how far they've traveled, and all this jazz. So here are the answers. Where are they? You need a map. You need a map to know where somebody is, right? How far have they traveled? They've walked 7 blocks. How far are they from where they started? They're 5 blocks away. And could they have gotten to the same place if they had gone 4 blocks west and then 3 blocks north? Absolutely.
So let's actually look at what that means, and by starting out with these terms. So distance equals the total length traveled. And remember that toolbox that you guys started to create from a previous video? Pull that sheet out and add these into it. Distance has no variable, and our unit is meters.
Right. So again, the student traveled 3 and 4 to make 7 total blocks.
Phenomenal. This is the same thing that a Fitbit would give you. It's the same thing a pedometer would get you. It's just how far you've gone. Displacement is where we start to get tricky.
So displacement is the distance between the final position and the initial position. So with displacement, we get a variable as delta x and delta y. Really just delta x horizontal, delta y vertical. Same unit as distance, a meter.
And then we have to go back to our right triangle trick. So what we say is the person walked 3 blocks north and 4 blocks west. This is where our map comes into play. If we have something that's 3 blocks north and 4 blocks west, we can say 3 squared, 4 squared is equal to the hypotenuse squared.
Right? And we will expand on this idea of right triangle geometry and right triangle trigonometry in future units. Now, this is the first equation that we get, so we're really breaking it down. We have delta x equals x minus x naught. Anytime you see a little 0 to the bottom right of a variable, that means the initial value, so initial position. And when you see nothing, we just talk about the final.
And I want to pull up this point, the fact that this is different than how our book establishes it, because our book is going to say xf as in final, but we're just going to drop that f and assume that any position that's not the initial position is the final position.
And that triangle, that is the Greek letter delta, and that just means change. Anytime you see delta or a triangle in math, we mean the change. So we're saying the change in x is equal to its final value minus its initial value.
So let's look at that practice problem so you guys can actually see an example of this. So remember, we're going to break it down. Let's go through our steps. So we need to set up our knowns, unknowns, and equations. So first we have to read the problem and rewrite it and annotate it.
So take a second, see what you can do, and then we'll compare. Okay, so when we see this, we initially see that the student started at a position marked 10 meters and walked to a position marked 20 meters, but then they return to that 10-meter position. So what I'm noticing is my initial position is 10 meters and my final position is 10 meters. So when I want to find my displacement, delta x, that's my unknown, I can use the equation delta x equals x minus x naught. Now, there's no equation or variable for distance because we understand that you're just adding up this distance, 10 to 20 and 20 to 10.
So let's look at, so really what we don't know is we don't know how the displacement. So we need to take our initial position, x naught, minus, we need to take our final position, x, minus x naught, our initial position, x minus x naught. So our math is pretty simple here. 10 minus 10 meters equals 0 meters.
So we've written the equation, we've substituted variables, and we've solved it.
So our distance, we went up 10 meters, we went back 10 meters, so our distance was 20, but our displacement, how far we've traveled total, is 0.